So today we are looking at the information systems development life cycle. Okay, so when looking at information system, just like any other system or just like any other object, an information system has a cycle. Okay, it comes to life, but before coming to life, it is first of all conceived. Okay, so it is conceived, it is planned, it is prepared, it is designed, it is implemented, it is rolled out or deployed, and then at the end of it all, it will retire. Okay, it will be put to rest. So first of all, I guess we all know what an information system is. We looked at what an information system is in the previous engagements. We know the components that make up an information system. Okay, so today we are looking at its life cycle, the stages, or call them the phases of system development life cycle. What are those steps that we are supposed to follow while implementing an information system? There are quite a number of them, starting from what we call, even before, of course, on the screen you are seeing planning as number one, but sometimes depending on which literature you are using, you'll find that sometimes, for example, talk about conception or conception, which is the stage at which the idea is developed. Okay, before planning, of course, first start by conceiving the idea or picking up the idea and then building it onto something tangible. So the phases are just like you are seeing on the screen. Of course, when we look at number 5 again, we are seeing it's the last stage. However, you find that we can look at after implementation, we can look at, for example, maintenance, okay, as another phase, and then finally retirement. So meaning when we look at what we have on the screen, there are those that are not in the generic structure of the process or of the stages that we are supposed to go through. But in some literature, you find that they are also pointed out. Okay, so in planning, looking at the phases on the screen, you'll find that in planning, we are looking at, among other things, reviewing the requests. Okay, seeing what the users want. Then from there, we look at the priorities. Much as the project is big, what are some of the key features that we should give more attention? What are some of the key issues? What are some of the issues that we can ignore? Okay, what are some of the issues that we can have a win-win? That is all to do with prioritizing the requests. And then from there, we need to put resources together, okay, to have the end result achieved. That is resource allocation. Then after mobilizing for funds or placing a budget on the project or giving it a vote, then the next stage is looking out for who is going to implement, who is going to do what, okay? Assigning tasks, assigning roles and responsibilities to different players that are involved in the information systems development. So that is the first phase. Okay, then from there we're talking about analysis. Okay, in analysis we are reviewing, we are trying to digest what is on our table. Okay, we are trying to understand it. Okay, so how do we understand? How do we analyze? We begin by conducting what we call the preliminary investigation. With the preliminary investigation, we are trying to get some facts, okay, available. For example, performing the analysis activities such as how does, before bringing this system on board, is there any other similar system that is in existence? If yes, how does it perform? Okay, which challenges does it have? Okay, what are the strong points of such a system? How can it be improved so that before building the system, you're able to know, first of all, what the problems, so that the same problems don't exist in the new system. And at the same time, it will also help in finding solution to those problems. Okay. And then we look at the phase number three, design. What is involved? What does it entail? Okay. You look at, for example, before getting a house put together, okay, you don't just start by laying bricks, okay? You start by coming up with a sketch of how this system is going to be, how it's going to behave, where will the window be, where will the door be, which kind of roofing, which design are going to use for the roofing, and so on, okay? So first of all, we start by acquiring what it takes to design, okay, and in terms of the hardware and software, and then giving the details, the nitty-gritties. You can look at, for example, the blueprint of a house and be able to tell how the end product of this house is going to be, okay? Why? Because first of all, in designing that house, you are simplifying the work of the project, whereby I just look at the plan and I'm able to see where to put what, when to do what, okay? How much is involved, how much is required to have the specific tasks done, okay? Then looking at phase number 4, implementation. This is when the practical work starts. Now, before going to implementation, for the case of systems development, just like I talked about having a plan or having a sketch of the house, if it is to do with building a structure, in information system development, you find that we shall come up with some diagrams, okay, that are going to give us a picture, such as, for example, the entity relationship diagram. You can actually read about whichever I'm going to mention here, such as entity relationship diagram, such as the context diagram, which shows the entity, the context of the system and its surroundings. For the entity, it shows you the different players and how they interact with the system. That is the relationship between the different players in the system. For example, look at ARMS or look at ODEL for e-learning, okay? You find that amongst the entities, we have an entity called the student, another one called maybe lecturer, another maybe called the administrator, etc. Then I'm able to look at all the surroundings and know that, for example, a student accesses course material. So such a diagram illustrates the relationships, okay? Such a diagram shows all those details, okay? Then we have what's called the use case diagrams, okay? They still show those details of what is going to happen within the system, okay? For example, we have what we call the data flow diagrams, showing the flow of data from or to the system. That, for example, a student registers like this, and this is where the data is stored, okay? A student requests for maybe something, and then so maybe an entity X gives the feedback, okay? All those details are shown, or they are indicated on the different tools, okay, within the system. So design is so key in as far as systems development is concerned. Then phase number 4 is what we are calling the implementation phase, which actually takes us to the practical work of developing, of building, of constructing the system, okay? Then from there we have number 5, which is the longest and the most expensive phase, which we are calling support, or sometimes it's called operational maintenance, or if you don't call it operational maintenance, we can just simply call it maintenance, whereby we are looking at keeping the system running, okay? Keeping the system running up and running to the expectations of the users. Just like when you construct or put up a house, it doesn't mean the end of the story. That house has to be maintained, and in some cases, the cost of maintenance is even overlapping or it is going beyond the cost of constructing that house. For example, there are daily bills within the house, there are those bills that are met on a monthly basis. There are those, for example, you want to renovate maybe once in a year, and so on. There are those that are met on a regular basis. So the same thing, if you look at, for example, your mobile phone, if the mobile phone you are having, you have spent much more money on maintaining it than purchasing or than acquiring that mobile phone. Okay, so maintenance is one of the key. Okay, and actually it's the most expensive phase in as far as information systems are concerned. Now, moving on, of course, there are those stages I didn't include here, like I told you at the beginning. Now we are going to talk about them in details, okay? For example, what are the guidelines for system development? What do you look at, okay? Before you can look at assembling the different components that you need to have available for the system to be assembled. First of all, it is always important to arrange or to assemble the tasks so that you know who is going to do what when. Okay, for example, we have a number of users, okay, or a number of stakeholders in this entire process from start to completion. So what is the role of SAN? So what is SAN going to do in the system? Who else should we have on board, okay, while we are looking at implementing our project? Which people or which stakeholders are required to be involved within the process or within the cycle? So the next slide shows us the different people or the different parties that are always involved in information system development life cycle, such as, for example, we are talking about, when you look at that screen, we're talking about the steering committee that acts as the link, okay, that acts as the driving force behind information systems development, okay. Then when you look at the steering committee, actually it is assumed to be the team of technocrats, okay, that are behind the entire process of information system development from start to completion. Then, of course, we have the programmers. I guess you know who a programmer is by now. These are the people who write the code. These are the people who practically implement the system. These are the people who you can call it building the system. Then we have vendors. Sometimes find that some of the components of the system are going to be outsourced, okay, from third parties. For example, assuming I'm going to develop a system, let's say for a database management system, okay. In fact, I'm going to, among other things, I will be required to use some software for building the system, which software is a third party, which software I'm going to get from third party providers, whom we are calling the vendors. So in other words, vendors do give us the different components or the different services that we need to be able to execute our mandate. Then, for example, we're talking about data analysts and communication analysts, For these ones, they're able to look at the data that we're going to use within the system and then recommend whether it is sufficient enough, whether it is of the expected quality, whether it is able to give all the details that are required. Then among the different stakeholders or participants in information system development are the users. So when we talk about users, these are the people that are going to sit on the computers, okay, and use the solution that we have come up with, okay? So, for example, me and you and I, okay, are users, and as far as Zoom is concerned, okay, we are the end users. Why? Because we didn't participate in developing the system, neither in doing any technical engagements, but we are able to use the final product at the end of it all when it is ready for consumption. So why is it important to involve the users? In most cases, why most of the systems fail is because sometimes the users were not involved. Meaning, however good the product will be, as long as the users don't appreciate it, okay, then that means it's as good as useless. Why? Because they are not able to use it. They will not embrace the system. So failure to embrace the system means that all the resources that we are invested in there, we are just wasted. So in most cases, these users will tell you what exactly they want the system to do, okay? That's why convincing them to be part of the project will be one of the key factors for the success of the project, okay? So these users, because the ones going to use the system, so that they're able to suggest better approaches to how they want the system to be implemented. In terms of specifying the features they want the system to be having, in terms of giving support in the entire process of implementing, okay? So at the end of it all, after involving on or bringing the users on board, all other nitty-gritties involved in developing the system become just a walkover. Then we are talking about data warehousing specialists. These ones are concerned more with managing the data within the data warehouse, okay? Ensuring that it's of the expected quality required. Then we are also talking about, besides those ones, we have what we call database administrators. Of course, any serious system, first of all, it's collecting data from the users, processing it, storing it, retrieving the data. So that means there is a database behind that system. Which database is responsible, which database is used for keeping the records within the system. Therefore, it requires that we have a specialist who is good at database management, who is good at designing the database, doing all the tasks, all the responsibilities that require having this information managed well. Then, after looking at the database administrator or specialist, you'll also find that we have other users such as management. Now we talked about steering committee and then management, okay? So steering committee, these are the brains behind the entire project, okay? Meaning they are the technical people in this case, in as far as supporting. For example, when we look at the system we have for Odell, yes, we have top management committee, but these people don't have much technical, may not even necessarily be having any technical skills in as far as such systems are concerned. That means in this case, maybe they involved the ICT technocrats within the university, okay? So that they're able to guide and manage the entire cycle. Then, so what does the management do? Of course, in most cases, for anything to see green light in an organization, it must get management support. Why? Because failure to get management support means that even getting the resources we talked about, okay, will be just a nightmare. That's why it's always important to have management on board to make management appreciate the relevance of having such a system in place. So once management appreciates the why we need to have a system in place, you find that the entire cycle is going to be a smooth journey. Okay, it's going to be a walkover from the time it started implementing from the time the project started being implemented up to the end. Then, of course, we have so many other players, such as, for example, network engineers, webmasters, etc., etc. We find that all these different players have got a role to play. Which role failure to bring them on board might jeopardize or might compromise the quality of the processes or the activities that are going to be executed. So, by the way, I'm on slide number 4, but you realize that I've already summarized or talked about everything you're supposed to cover. Now, I think I need to engage with the members right now so that they can tell us, for example, on arms, let's look at arms in this case and try to identify the different stakeholders. No, let's use Odell, because I'm sure most of us have already used it. Much as you are already in the university, but I'm sure you've not used arms already. So let's look at Odell and try to point out the different participants or stakeholders in such a system. Given what I've just explained and given what's on the screen right now. Yes, members, can we have the discussion going? Thomas. Yes, Thomas, can you speak to us? I think he's absent. Who? Let's have Solomon. I think none of them is present. So am I speaking to myself? I don't know. Am I speaking to myself? It seems members are not present.
The IT department.
Sorry. Okay, I've got that one already.
It is
talked about IT department. Yes, I get it. I've got your point.
Who has said
Let me hear from another person. Okay, thank you very much. Then Ephraim has talked about the teaching staff. Okay. And then Selinda has talked about the webmaster. Okay. Yes. Let me get other people's submissions. I'm waiting for other people's submissions, then we continue. I want each one of us to give us, say something. Herbert. Herbert, can you speak to us? Okay, so it's like members are not willing to participate. So I've tried to explain each and every component that I've already mentioned up. So who the analyst is, what they do. So this one is acts as the liaison between the users and then the experts. Okay, so that is able to know what exactly the users want. First of all, to make the users understand what is going to be done and appreciate them. Then at the same time, on the other hand, to make the professionals or the experts understand, okay, what is expected as the end result at the end of the project. What is required to be done? Okay. So that is the role of a systems analyst. Then we have other players. Then while developing the system, okay, or while implementing the system, you will find that we have other things that are supposed to be done in the background. For example, it is important to do what we call feasibility study. What is feasibility study? When we talk about feasibility study, we're looking at analyzing the environment and look at and be able to see whether this project is achievable or we are likely to hit a dead end. Okay. For example, in terms of finances, do we have all the resources required financially? That's a question. Okay. Okay. Maybe we have the resources available that are required, but does the system or does the project, or will it be able to have economic value? Will it be able to add something onto us, onto the organization, much as we have all the money, but we want the resources just be wasted to invest them in such a project? Okay, that is all feasibility study. So meaning you don't just wake up and start implementing a system. Okay, you must first analyze, okay, and look at it from all angles. See to it whether it is really required for the project to be done. Okay. Then under feasibility, I've talked about, of course, there are different types of feasibility study, such as operational feasibility. It is one thing to implement a project or to build a system, and another thing for users to be able to use it or to appreciate it or to accept it. Will these people really be able to operate the system that you've implemented? I've heard about cases or instances whereby you find that yes, we have a running system in place, but maybe the users can't operate. We need to get expatriates actually from overseas. Okay, meaning should these expatriates not be willing to come and do the required, to do what is required, then that means that the system or the project is going to be as good as useless. So all those different feasibilities are so key. Schedule feasibility, okay? For example, we are now in November, towards the end of November. Should we have a schedule? Requires us to implement, to have the system ready, maybe by the first week of December. Okay, given the remaining time, given the required resources, given what we have at our disposal, will this really be possible? Can we really achieve this? Okay, so all that is done during the feasibility study. Then we have talked about the technical feasibility. It's looking at having all the required skills, okay? The technical expertise that is required to implement the project. It is one thing wanting something, and another thing having the capability or the capacity to implement, okay? For example, imagine you want to work out a system whereby it requires us to connect the satellite. Do we have all it takes in terms of the technologies that are required? Okay, so all those are just some of the issues we are supposed to look at to see whether the project is feasible, whether the implementation of the project is feasible or not. Because having embarked on something which we are not sure of whether we shall be able to get to the end, okay, it will be a waste of resources. Imagine, for example, you want to construct a house, okay? You didn't look at what it takes. You waste your maybe 5 million, you invest in materials. Then at the end of it, often that you don't have all it takes to have the house. completed. Meaning, first of all, you will not have that house usable, okay? And at the same time, you cannot get back your resources that have already been invested. That's why it's always important first to analyze each and everything to see before you start on the journey. First, look at the possibility of getting to the destination that you want to get, that where you want to head. Now that we've looked at feasibility study, we, of course, documentation, okay? You find it whichever for serious projects, okay? You find you have to document each and every course of action that is taken, okay? Right from the planning, you're supposed to document the planning, how planning was done, who was involved in doing what, and so on and so forth, okay? Who is going to do the designing, who is going to do the training, the deployment, the maintenance, all those details is so key. And then, of course, in documentation, we find that also, among other things, we're also putting the steps, okay? I've always come across different applications or different solutions. And you'll find that within those solutions, I can use the solution without having to meet any of the people who implemented it. Why? Because they documented it, they documented the steps I'm supposed to follow to have certain things done. Then, so that is it with documentation, that is collecting data and information and then reports. Even the design is also very important to be documented. How you did the design, okay? Which deliverables are expected, okay? What does the system do exactly? All that. So now that I've talked about collecting data, okay, while doing my documentation, how do you collect data? Okay, you find that there are a number of skills or techniques you can use, such as document review by looking at what similar systems exist and how were they done, okay? Then by observing what is happening, how people are using the system before, the existing system before you come up with this new system. Then we can have questionnaires whereby you can ask people to give their feedback on certain aspects, interviews, and so on and so forth. Then, why is it important to create a system? Okay, why should the system be created, or why should it be modified? Sometimes we are coming up with a new system whereby there is nothing in existence. Okay, there is nothing that is in place yet. Okay, then sometimes you find that yes, there is something in existence, but at the same time, you're coming up with something new again. Okay, so when do we come up with something new? Okay, and when we modify an existing solution. Okay, why we always come up with the modified versions is because maybe the one we are having is having a problem. Okay, for example, I've been having a system for learning which is face-to-face, whereby I go to the university physically, meaning by now I would be at the university right now I speak. Okay, then I teach, get back home. So that added issues in this case, okay, whereby under certain circumstances, for example, when we are trying to protect ourselves from whichever is happening, okay, we cannot operate. So how can we ensure that the system we have in place can run regardless of the situation? Okay, so that means there's a problem, and therefore want to correct that problem. Okay, to allow for operations regardless of the circumstances. Okay, then another reason as to why we might have a system or to create a system or to modify is, yes, we have the system in place, but it's having some, okay, it is not having any problem, yes, but there are certain things we can add, okay? We can make it better, okay? For example, we have that order. Event, yes, it is in place, but maybe we realize that there are certain components we can incorporate there to make it more robust. Okay, so that one might also another cause for us to come up with a new project. Okay, to come up with, to build a new system, which system is looking at making the existing system better for that, so that it's able to serve so that it's able to serve, I mean to serve better than it is serving. Then it could be because of existing changes. Okay, maybe an external force. Okay, for example, government can require that all academic institutions are required to have a system that is supposed to do a certain task. For example, e-learning. You may find that maybe they come up with the resolution, National Council for Education, that any institute to be licensed must be having provision for both face-to-face and online. Okay, so that in the future we don't have to go through all these challenges we have been going through, by in case there is no face-to-face, then nothing is taking place, no learning is taking place. Okay, meaning it is a force, it's an external force, it is a requirement, maybe by law. Okay, so maybe all hospitals are supposed to be having such and such a system in place. Maybe banking institutions are supposed to be having such and such in place. Meaning it is a mandatory requirement for example, we have those telecom companies. Previously, you could just go and buy a SIM card on the street and you put it in the SIM on the mobile phone, it's able to work. Okay. Currently, you can't do that. Meaning, telecom companies were forced or were mandated to do what? To develop systems, systems which can allow for subscribers to be registered. Okay, and which systems are able to connect to the national database. Okay, so that it's able to verify with the names the names of the subscribers against their national IDs. Okay, in NIRA. So sometimes you can have it is a mandatory requirement. Then also competition. Okay, of course, when you go into business, you're looking at survival amidst the challenges. How can we exist and ensure that we are able to survive? Okay, so if you are the kind who is operating, for example, look at academic institutions again. If I may use the same example, you will find that if you are a new player, most of the institutions are now operating both online and physical. Okay, meaning we're able to tap into the market of, let's say we're in Uganda, but we're able to tap into those that are from Sudan, students from Kenya, students from all the world. Okay, and for your case, you're only operating physically. That means, okay, that means that you cannot compete at all. Okay, you'll be out competed. Where we're able to get, let's say, 100 students from different corners of the world, for your case, you can only get maybe 10, okay, or even less with that from within the neighboring community. So that's why it's always important to look at the environment and see what can push us forward. Of course, among the solutions, you find that you have to come up with a computerized system that can be able to give you mileage in as far as operations and business growth is concerned. So what is a request for service? Sometimes, anyway, I think this one we can skip. So we have looked at the key issues in as far as information system is concerned. Why should a system be created or modified? We have said that first of all, to correct a problem. Then we have also said to improve. We have also said sometimes it is a requirement. Okay. I gave an example. For example, you find that when national IDs were in place and then telecom companies were required to have their subscribers registered, they were forced to come up with systems which can allow for registering their users. Okay. Then you also find that maybe, for example, I talk about again another example of universities. You find maybe National Council can review its policies and say that from now onwards, to license an academic institution of higher learning, you must be having at least 2 options for learning, that is both face-to-face and online. Okay, to be able to cater for the eventualities that can come our way. Then I've also talked about competition again, using the example of if you are to operate an academic institution face-to-face only, meaning those that are having both might leave you thousands of miles, okay, behind. So that means that competition alone can drive you to rethink and look at having a computer-based information system in existence. I talked about what is in planning. I think I've already discussed all of this. In planning, we're looking at what do we need to have this work done? Okay. Have we approved what we are required to have? And which tools or which tasks need more priority? Then who is concerned with allocating resources? Okay. And then finally, building the development team for the task or for the assignment. Then in planning or in analysis, amongst the tasks, I've already talked about actually preliminary investigation, okay, which is feasibility. So it is always important first, before you embark on something, you weigh in, you measure and see how achievable is this. Is it a far-fetched dream, or it is something that we can achieve? Okay, all this has already been explained. Then the detailed analysis shows how the system is going to work, how the current one is working. Okay, what are the gaps within the existing system, and which recommendations do we give? Okay, I think all this has already been explained in my prior explanations. I may not need to waste a lot of time discussing all this. How do system analysts test the software? Sometimes find that you can talk to the users, whereby you give them the system, they work it out, have a feel of how it works, and then give feedback. Okay. Sometimes find that you make a product and then give trial versions of the product for the consumers to use it and then try to review, and so many other ways. Okay. So I think all this has been explained. So if amongst the steps we have to look at, among other things, giving a mock-up project system whereby you have something that is able to capture information that users can use, okay? Just to have them get a feel and see how it's performing, whether it's doing to their expectations or not. So this is what we call the prototype actually, which is a working model of what the final product is going to be like. I talked about the design, and I talked about different tools for modeling the system, such as the context diagrams. So in other words, you can use the computer-aided software design tools, okay, to design our system For example, when you look at what is showing on the screen, I can just look at this illustration here and know how the system is going to work. Who is going to interact with the system? Okay. And what is their role in the system? Which feedback does the system give? Then I think I've already talked about all this. Of course, you find that after implementing the system, you have to look at, for example, rolling it out, training users, okay, testing the system before even rolling it out to ensure that it's able to achieve the purpose or the objective which it was designed to implement. Now, there is a stage, of course, before implementation or before rolling it out for the users, it has to be subject to testing, okay? So we have got 3 types of tests that we are supposed to always subject systems to or software to. That is, we have what we call unit testing. For example, assuming let me give the most basic example. We have that website of the university, okay? You find that on that website we have pages, okay? For example, we have home, about us, contact us, and so on. I will develop each one of the pages independently, and I test whether it is showing whether it is showing that it's supposed to show, whether it's having everything that it's supposed to be having. Okay. So meaning I'll do the same thing for all the pages. Okay. Then I'll do what we call integration testing. Now, if one component is able to work on its own, okay, how about if I put all these components together? If I assemble the components, the way you see that we have a car, which cars different components, each one of them is okay. For example, the tires are okay, they are well inflated. Maybe the engine is okay, it is well lubricated. Maybe you can think of maybe maybe the fuel gauge is okay, maybe the AC is okay by its own. How about if I put all these components together? Okay, can they be able to, at the end of it, or will the car be able to move? Okay, that's what we're calling the integration testing. As after assembling all different components, are they able to work as one unit? Then, of course, training is also one of the key components, so that the users at the end of it all are able to work with the system, okay, effectively. Then, much as I've talked about only this, we have what we call maintenance. Okay, with maintenance, first of all, looking at the system, whether it is having errors, whether if it has errors, how can we fix those errors all the time, ensure that the system is working very well? Then how can we enhance the system? For example, by the time we develop the system, we had 1,000 students, okay? But as the numbers grow, we find that the system becomes too overwhelmed, okay? Traffic becomes too much and the system cannot handle anymore. So how can we fine-tune the system, okay, to ensure that it's able to support, okay, the growing needs from the users? Then monitoring the performance. For example, is the system secure? Can't it be hacked? etc, etc. And then after looking at all those phases, at the end of it all, the system reach a point whereby it cannot be maintained any further. Okay, just like you can buy a shirt today, it develops patches, it develops holes. Okay, then you keep giving it patches every now and then. Okay, time will come when you cannot repair it anymore. You have to put it trace and then get a new shirt. I think that is it for today. We're going to stop here until next week.